This is Chapter 3 physics problem, projectile motion, OpenStax physics textbook number 42. Question number 42. So a soccer ball is kicked 30 meters from the goal and it just passes over the top of the goal, which is 2.4 meters above the ground. If the launch angle is 40 degrees, what is the initial velocity of the ball? So you can see here, I've already drawn a picture. And that's one of the important things when you're doing these questions like this, is to draw a picture and kind of write down what you know. It helps you organize your ideas and also helps you think about what you're looking for. In this case, I know theta, I know this distance, I know that distance, which I'm going to write down in a second, but I'm looking for that angle theta. Okay, so for projectile motion, we know that in the x direction, I can write the following motion I'll put it as x motion, put it a little bit higher, I got room, x motion. I know that I have my final x, I know my initial x, I know my initial x velocity, which I can find. I don't actually know that, but I can kind of find that. And there's time. So which of those do I know? Well, I know my final x is going to be 30 meters. I know my initial x is 0. I don't know that, and I don't know that. But I can go ahead and write two things. I can say Vx0 is V0 cosine theta. Because I know theta, right? That's if I know my initial launch velocity, if I did, I could find the x component of that using the adjacent side of the right triangle, and I get that for my x velocity. But I don't know V0, I don't know theta, I don't know time. So I'm kind of stuck. I do have the kinematic equation x is x0 plus Vx0 t. That's true, right? Because it has constant zero acceleration, so that's my kinematic equation. So I know this. I can write this as 30, 0, Vx0. I can even put in what I want, t. But the thing is, if I knew time, if I only knew the time, then I could find the initial x velocity, and I could use that with my angle theta to find the initial velocity. But I don't know time. Jump over to the y motion. What do I know about the y motion? Well, I have my final y, my initial y velocity, my time. So which one of those do I know? I know my final position is 2.4. I know my initial position is 0. I know my initial velocity is V0 sine theta, right? Because that's the opposite side of that right triangle right there. And the time, I don't know that time. But I can write down my kinematic equation for the y direction. I'm going to put it over here just to have more room. y0 plus vy0t minus 1/2 g t squared. If I put in the things I know here, I know y final, 2.4. I know y initial 0. I'm going to go ahead and put this as vy0. I'll just leave it like that. Let's put this as v0 sine theta. That's my initial y velocity. T minus 1/2 g t squared. And sine theta is just a number, right? It's sine of 40. It's just a number. Okay, so right here, I don't know V0 and I don't know T. Here, I don't know V0, and let's write this as 30 equals V0 cosine theta T. So I actually have two equations, two unknowns. Let's do a trick here. What I'm going to do is to solve this for time, plug it in over here, and I'll have an equation that only depends on V0, and I can solve that for V0. But since I have two equations, and I have two unknowns, and whenever you have two equations, two unknowns, you should be able to solve them. Okay, I'm going to go ahead and get this and this as a number, because I think you'll like that. You'll like that a little bit better. So let's see. Drop that sine of 40. Make sure your calculator is in degrees mode. So that is, let's put it right here, 0.64, and then the cosine of 40, 0.77. So let's solve this for t. So if I solve that for t, I get t equals 30 divided by 0.77 v0. Now I can take that expression for time and plug it into this equation right here. So I'm just going to write this out. 2.4 equals v0 times that 0.64 v0 times t, but t is that 30 over 0.77 v0. Notice what happened there. The v0 is going to cancel. Minus 1/2 g, no, I'm thinking ahead. 1/2 g times t squared, but t is this. So I have 30 over 0.77 v0 quantity squared. Now let's just rewrite this equation up here with a little bit more room. I don't need any of this anymore. Okay, so I'm going to write this equation, and it's going to simplify things. So every time there's numbers I can simplify, I'm going to simplify it. So I get 2.4 equals. Now here I have 0.64 v0 divided by v0. Those v0s cancel, but I have this number. So I'm going to multiply this out and get this thing as just one number. So I have 0.64, enter, 30.77 divided by, I get 24.9. So this whole thing is 24.9. That whole thing. And now I have minus, I'm gonna put all this stuff together, right, except for the v0. So here I have 1/2 g times 30 squared over 0.77 squared v0 squared. So all that other stuff is just a number. I'm gonna get that as a single number. It's negative, so I have, that's a 9. Minus, let's just put this in here, 0.5, 9.8, 30 squared, and then 0.77 squared divided by. And that gets, whoa, that's kind of a big number. That's fine. I'm just going to go with it. I could be wrong, but you'll never know. You know why? Because I just delete the video and start over. It's true. It's true. Okay, 7438 minus 7438 over v0 squared. So now I just have to solve that equation for v0. Well, let's subtract this from both sides. So I get 2.4 minus 24.9 equals negative 7438 over v0 squared. That's just a number. 24.9 negative 22.5. So the negatives cancel, so I get 22.5 equals 7438 over v0 squared. I'm going to multiply both sides by v0 squared, divide both sides by that, and I get v0 squared is 7438 over 22.5. That's just a number. 7438, 22.5, 330.6. Now what do we do? Well, now I just take the square root of both sides. So I get v0 is going to be the square root of 330.6. And I just go square root. 18.18. Plus or minus, okay? It's actually plus or minus mathematically, but that doesn't really make sense to have a negative velocity here. We already said the direction and so forth. So let's just take a step back here and look at what happened, right? Because it may seem like an overly complicated problem. It's projectile motion. I wrote down everything that I needed and what I wanted to find. There was two things I did not know. I did not know the launch velocity, wanted it. I did not know the time, didn't need it. So once I wrote down my x and y equations, I had two equations, the x equation, the y equation, and two unknowns, the velocity, the initial velocity, and the time. So once you get in a situation like that, you can just solve the one equation for one variable, substitute it into the other equation, and solve for what you don't know. And then that's what we did. So the rest of it was just algebra. And I admit, it got a little bit more algebraic-y than you would normally expect. But if you trust the math, once you write down those equations, it's just doing a math problem. Okay, it's not that bad. And there you go. Now, is it possible to check your answer? Yes, it is possible to check your answer. What you could do is to take that launch velocity, go back to the initial problem and say, okay, I'm going to launch it at this angle with that velocity. Where does it land if it's 30 meters away? How high is it? Or how far away would it have to be? So you can do the projectile motion problem again. Now, you may, if you did this, you may get a slightly different number because when we're dealing with squares and square roots, rounding matters a lot more. So just be aware you might get something that's slightly different. But the idea is the same. I rounded some just because I just don't really care.